welcome to the session. In this video, we'll be discussing about the next kind of hypothesis testing, that is t-testing. So before I start, I request all of you to please like, share and subscribe to the channel. So t-test is basically a statistical test which we use to determine if there is a significant difference between the means of two groups. So this is one group, this is another group, this is the mean that you're seeing here, the dotted lines. So basically here using t-test we try to find the difference between the means of two different groups. Normally when you are doing a hypothesis testing, you might feel that should I use z-test here or t-test here. So one way to easily identify is if the number of samples is greater than 30, then you can directly go for t-testing. And t-test follows a t-distribution under the null hypothesis. T-test follows more of a t-distribution, I can say, rather than a Gaussian distribution. Now what is the difference is, the blue line which you see here is the Gaussian distribution. The red line you see here is a t-distribution. Both of them looks like a bell curve. Both are symmetrical, both are bell-shaped, but the difference is in the tails. In the t-distribution, you can see that the tails are much heavier as compared to the Gaussian distribution. So that's the difference between t-distribution and normal distribution. Now there are three types of t-test: one sample test, independent samples test and paired samples t-test. In one sample t-test, we compare the mean of a sample. This is the sample. So we compare the mean of the sample to a known or a hypothesized value. So in this example, you see here, this is a mean, this is one group and this is a mean of the group. So we compare the mean with this known value or a hypothesized value. In the second type, that is independent samples t-test or two sample t-test, we have two groups which are independent of each other. So we compare the means of these two independent groups. In the third one, we again have two groups. It's called as paired samples t-test or dependent samples t-test. So as the word itself says, the groups are dependent on each other. They are not independent like type 2. So that's why you can see a line here. So the groups are dependent of each other. So here we compare the means of two related groups. For example, if I'm taking measurement of the same subject before and after the treatment. So that is a paired samples t-test. So one thing we assume here is the data should be normally distributed. When you are applying t-test, the assumption is the data is normally distributed. Now this is an example of a one sample t-test. So what you see here is, this is a manufacturer, right? The manufacturer of a chocolate bars. He says that the chocolate bars he is manufacturing, it weighs 50 grams on an average. Now to verify this, now we do the verification. We verify a sample of, let's say 30 bars. We weigh it and we compare it to a standard or a reference value. So here we are comparing the means of 30 bars of chocolates with a reference value. So let's say the reference value is 48 grams. So that's an example of one sample t-test. So we are comparing a sample with a reference value. In this case, let's say the reference value is this, which is saying 48 grams and the factory is saying 50 grams. So we apply here t-test to find out whether the hypothesis is correct or not. That means we are going to accept or reject the hypothesis, the null hypothesis, because in this case the null hypothesis will state that the mean is equal to mu naught. Mu is equal to mu naught. So that would be the null hypothesis here. So that means we perform a sample t-test to see if the mean of 48 grams is significantly different from the claimed 50 grams. So that would be the t-test here. In the second example, for a independent samples, for the second type of t-test, we are taking an example of two different groups which are independent of each other. So we are comparing the effectiveness of two painkillers, drug A and drug B. Since we are comparing the effectiveness of different drugs, the blue one and the yellow one, this is an independent t-test. So here we apply independent t-test to test whether there is a significant difference in the pain relief between these two drugs. So coming to the third type of t-test for paired samples. So here we are taking example of 30 people. We are weighing them before the diet, and the same people we are weighing them after the diet. Okay, so the population remains the same people are weighed, and the number of samples are also same. 30 people we are weighing them before the diet and after the diet. Since the group remains same, right, the comparison of the group remains same, this is a paired samples test, because the samples of the two comparisons is for the same population. So that's why we call it as also as dependent t-test. So we apply here dependent t-test to check whether there's a significant difference in the weight of the people before the diet and after the diet. So in this case, null hypothesis would be what? Mean of the weight before the diet is equal, we are checking whether it is the same as mean of the weight of the people after the diet. So in this case, null hypothesis is mu is equal to mu naught, where mu is the mean of the weight before the diet. Mu naught will be the mean of the weight after the diet. So the steps that we use. So how do we calculate the t-test? So what is the formula for calculating the t-test? So generically seeing whatever the type of t-test is, basically we are doing a comparison of the mean. So first thing is we need the difference of the mean, and second we need the standard deviation from the mean. So two values are important, the difference of the mean and standard deviation from the mean. So that is what is t. So the generic formula is t is equal to difference between the mean values. See, this is one mean, this is another mean, irrespective of which type it is. So difference, this is the difference between the mean value divided by standard deviation from the mean. So that would, standard deviation will from the mean will actually give us the standard error. So the formula for t-test for the type 1 of t-test, the type 1 is where we are calling it as sample t-test, where we are calculating the difference between the sample mean and the known reference mean. So the formula is like this, where t is equal to x bar minus mu. Basically the numerator is a difference between the mean values. X bar is the mean of the sample and mu is the mean of the reference we are taking for this first type 1, divided by standard deviation from the mean. What is the standard deviation from the mean? Is s divided by root of n, where s is the standard deviation and n is the number of cases. So use this formula for if you are calculating t-test for the type 1, that is for sample t-test, where we are finding difference in mean between the sample and the known reference mean. Now the second type, this is the formula for the type 2 t-test, where I am comparing the t values for independent samples, so the samples which are different from each other. So if I have to find the difference between the two sample means, then the formula is like this. See, the concept remains the same. Numerator is difference in the mean. So difference in mean of sample 1 and sample 2. So mean of sample 1 minus mean of sample 2 divided by, concept is same, standard deviation from the mean. So what happens now is the same formula I will be changing it for S1. In S I will now include S1 and S2. So root of S1 square by N1 square plus S2 square by N2 square. Now for the third type, for the paired sample test, where now they are dependent on each other. Now the group is the same, right? We are doing before and after. For the same group, we are finding the mean difference for the same group before and after. So what happens to the standard difference in mean will be xd bar minus 0. So basically it will be xd bar. Basically what is xd bar? I am finding the mean value before and after, divided by, see, standard deviation will remain the same, divided by root n. So the denominator will remain the same like in type 1, s by root n. So these are the three different formulas depending upon which type your problem is. You need to identify your problem, then depending upon which type it is, you have to apply the formula. So one more concept that is very important is, before you start the problem, is you know the goal, right? What is the goal of t-test? We use the t-test to find out whether we want to reject the null hypothesis or not. So basically all tests are same. Z-test, which we have discussed in previous videos, t-test in this video, chi-square test. The goal is same. We want to reject the null hypothesis or not. So what is the method we use here is like we have done in set z test, which we have done in the previous video, where we were referring the z table. So in this case we will be referring the t table. Okay, so either we will be reading the so-called critical t value from the t table, either we will be doing that, or we will simply calculate the p value, that is a probability value, with the help of t value. So we will be doing either of these two methods to find out. Okay, so most of the problems which I'll be doing, we'll be doing only with the first method, where I will find the critical t value from the t table. So this is the t table. Okay, so when you are given a problem, you should be given the table, right? So this is a t table. This is the significance level which you are having on the top first row, and the column is actually the degrees of freedom. df is the degrees of freedom. So if the significance level is given in your problem as 5%, then come to this row. 5% means 0.05. The difference, now this is a t table for two-tailed. Okay, so 1 minus 0.05 is 0.95. So under this, and if they give the degree of freedom as 9, so it coincides here. Okay, so if we choose a significance level of 0.05, then we look into the columns at 1 minus 0.05, that is here. Okay, now based upon what is the degree of freedom given, you choose your critical t value. So in the problem you also have to find out that means to see this table you should know the degree of freedom, right? So to access the table you should know df, degree of freedom. So degree of freedom formula is also different for the different types of t-test. For first one sample t-test, it is number of samples minus 1. For independent samples t-test, because I have two different samples, right, n1 and n2, so it will be n1 plus n2 minus 2, because it is two samples here. And in the paired samples t-test, it is the same sample, right? So that is why it is the same as first one, n minus 1. Okay, so remember this formula for degrees of freedom. Now in the next session, so that was about the introduction to t-test. In the next session I will discuss problems on t-test. Thank you so much, and please subscribe to the channel. Thank you.